All right, so let's talk supercomputers and HPC.
And AI is actually a highly demanding HPC application that needs a high-performing infrastructure. The big challenges of an exascale system, right, are really that of power efficiency, performance, and how do you system administrate such a big complex system. I think DDR5 memory bandwidth and efficiency scaling are key to HPC in attaining the best bytes per clock per watt.
So is there a new HPC project that you are working on that you find to be particularly interesting at this point?
Yeah, I don't want to get in trouble with my customers, right? But I have several projects.
Hey everyone, my name is Jim Elliott, the SVP of Memory Sales here at Samsung, and I'm excited to be here hosting our fireside chat with Intel's Nash Palaniswamy. We're going to be talking today about how HPC, supercomputing, and future technology collaborations will help power industry innovations and improve the world around us. Everything from healthcare and environmental safety to energy advances and beyond. So to kick things off, let's welcome Nash Palaniswamy, VP and General Manager of the Sales and Marketing Group. Nash is responsible for winning Intel AI, HPC, and data center accelerator solutions for data center customers and delivering the overall AI and HPC revenue for the data center group. Outside of work, Nash's passions revolve around sports, which include weekend golf and cricket, supporting his wife in achieving her weightlifting goals. That's pretty cool. And spending time with his two beautiful children and two furry four-legged family members. So with that, I'd like to say welcome to Nash. And Nash, it's great to see a new face here, even if it's via Zoom. So before we get started, maybe just to kick things off, how has life been for you and your family during the pandemic?
Well, firstly, Jim, it's a pleasure meeting you virtually, and huge thanks to Samsung team for allowing me to be part of this fireside chat. You know, and I think you mentioned Intel solutions, right? I actually sell a lot of your solutions as part of the
All
complete
right.
solution to the customer. So extremely excited to have Samsung as a partner in this journey, right? Life during the pandemic, it's been challenging for all of us, right? And I think all of us have been directly or indirectly impacted by COVID in some form or the other. And I'm just praying for all the people who have been affected by COVID and hope things better, right? And some of the things that has really stepped out to me, right, is like the way that all our companies have contributed in some fashion or other, right, to overcome the pandemic. Intel invested a lot in our pandemic response technology initiative, and I'm hoping our collective efforts, right, as responsible companies in this world and citizens on this world will bring us back to normal soon. Right?
Definitely. And again, I think it's interesting how the sort of the IT has been sort of the backbone of that digital transformation that has allowed us to sort of navigate through this pandemic. So yeah, definitely. All right, so let's talk supercomputers and HPC. So, Nash, Intel is at the forefront of the HPC market, which is fueling so many important innovations in computing today, especially with the advent of AI. And you see firsthand how HPC is changing both in terms of customers as well as use cases. So what kind of exciting new capabilities and use cases are you seeing nowadays?
Yeah, I think, firstly, I'm blessed to be in this field, right? Since the 80s, I remember at some point in my career, I said, you know what, I'm not going to get a job doing HPC when I finish my PhD. But, somehow I get drawn back and, I'm really in one of the computing fields, which is making a huge difference, right, to pretty much, every person on this planet, right? So I like to explain HPC where it is today and where it's going, so you can kind of look at the new capabilities and use cases, right? HPC is really a combination of two things, right? A high-performing infrastructure, right, and highly demanding applications, which need such an infrastructure, right? And the application needs all kinds of things, right? Floating point memory, math is one typical thing that you can think of. But there's lots more to an application than this pure math, right? Or a general purpose processor. Memory bandwidth, right, is a huge need. Memory capacity is a huge need. Large storage and fast storage is extremely important. Low latency communication, network bandwidth, all of these are extremely important to go create these, HPC applications, right? And AI is actually a highly demanding HPC application that needs a high performing infrastructure, right? And it needs a lot of these things. So people get confused. That's the way I, look at it simply. It's a high performing infrastructure and demanding application, right? And right now I'm seeing AI being infused in typically every HPC application, right? Whether it be weather, CFD, imaging. And my bet is that it's going to be pervasive, right? It's one of the big inflection points. And whenever I keep talking, right, there are two big inflection points happening. One is AI, pervasive AI, and the second is memory and storage, right? That is really changing the way that computing and technology is going to go forward in the future, right? And if you look at HPC today, I think everything around us today uses HPC in some form, right? Our medicines, vaccines, our cars, our laptops, our golf clubs, and the list goes on, right? And processors, memory, storage, network, right? Together, they play a huge part in the final solution, right? And everything is data driven today, right? And accessing large data at high speeds is super important for an app, even to take the first step, right? So accessing large amount of memory is needed to get better precision, right? Especially like in medical science, right? And this AI HPC convergence is the new trend, right, that I'm seeing, right? And accessing memory at high bandwidth is super important for applications, right, that need to keep the CPU busy. So AI and HPC convergence is driving a lot of these new capabilities and new needs, right? So let's talk about trends. I think you asked the question, what are the trends that I'm seeing, right?
Sure.
So, if you look at, the high performing infrastructure industry, right? It's pretty much been CPU dominated, right? In terms of, uh, the actual infrastructure used for these demanding applications. But heterogeneous computing is now becoming more mature, right? And the big trend I see in the next 4 or 5 years is that you're going to see the need for an open standards programming environment, right? Which is what people need so they can plug and play an FPGA, an accelerator, an ASIC, or a GPU, right? And it's super important for the industry. And that's why we're driving like the industry standard open one API effort, which is very important, right? Just like how USB and PCI Express came about so that there's a thriving ecosystem. In order to have a thriving ecosystem for heterogeneous computing, I think you're going to see that big trend in terms of what you're going to see in a high performing infrastructure, right? And of course, you hear about quantum computing and neuromorphic computing. It's going to happen. It's not going to happen in the immediate future. Neuromorphic will probably happen before quantum. But when it does happen, I think it is going to be benefiting, all of us in a way that we never imagined, right? The exploration space in quantum computing is going to be so huge, right? I mean, if you look at a computer which plays chess today, right? The exploration space is really, within, what you can imagine within a computer, right? With quantum computing, and the idea of qubits and quantum, and entanglement, you have this exploration space which is huge. So, but we need to get to a stable quantum computing environment. It's going to take some time, and I think there's very interesting trends happening in the future from a quantum computing standpoint.
Thanks. That's a great overview. So thank you for all that. So maybe let's transition a little bit to talking about some of the benefits. So tell us more. You touched on it earlier, where it's kind of all pervasive in terms of the implications and the areas that can have an impact on. But how do you see some of these new capabilities or use cases either benefiting consumers or humanitarian causes overall?
No, absolutely. And, I mean, I can give you a lot of examples from the consumer standpoint, but I'm going to jump into some of the humanitarian, thing because of all the COVID pandemic that is happening. Incredible examples, right, of HPC at work to improve life, on this planet, especially in this stage. For me, the lucky part for what I do is I see customers work, right, on how HPC is making a difference. And, and I'm going to focus on some of the health and life sciences research, right? But we've seen some unbelievable advancements, right? Thanks to HPC. Cryo EM, technology uses HPC, and that allows you to visualize viruses, right? Before you used to have, X-ray crystallography, but you couldn't really do, image viewing for larger organisms. Okay, so using cryo EM, whether you can actually like freeze, the virus, and then use 3D image construction techniques to look at the virus. That needs a lot of computing, and cryo EM is a way by which we have visualized viruses, right? And then HPC algorithms to find out variants, right? So when you get a blood, sample, you run it through your sequencing machines, and then run it to a big computer. The sequencing machine is going to get you a big text, but then you need all this crunching to go figure out which variant is there, right? If it is there at all, right? And so those are some of the things, right, that have been used to go make vaccines, right? Vaccines are formulated to defeat the virus cloaking of spikes, the spike protein in COVID, right? So some of the research done, on some of these big supercomputers found out that the virus had a cloak, and so you could go and get a vaccine to go figure that out, right? So all these are exciting, right, from a pure health and life sciences standpoint. And then you have the neuroscientists working on models of the brain, right? And it's getting closer and closer to the real brain. And as computing, and memory and storage and networking get, better, you're going to see more and more advances in that space, right? Compared to our knowledge and our models of the human brain 10 years ago. Okay.
Good. Those are great examples. There's obviously a lot of changes that are happening concurrently in our industry. And what do you see as, what are some other factors that are behind this that are driving some of these changes that are having these impacts?
Yes. So, having been in this industry for 32 years, right, I strongly believe in this technology innovation loop, right? As technology advances, right, innovation increases, and that causes a corresponding technology advance, right? And everything starts with data in my mind, right? Which is with more data available and better technology to move, process, and store the data, more innovative algorithms are being built, right? If you look at what happened to AI, for example, right? I mean, I took an AI course when I first landed here in the US in the 80s. And I never thought that it'll become a reality, right? But then with all the technology advances, sometime in 2012, right, a big boom happened, right? All the technology was ready to take this AI into mainstream, right? And what happened in computer vision and natural language processing is, you could see that, driving the change, right? So human beings adapt to challenges, quickly, as we have seen during the pandemic, right? And innovation has been at its best, right? And HPC is, at the heart of finding a solution, right? Like I mentioned, visualizing the virus to create vaccines, AI systems to identify COVID-infected lungs, and the list goes on, right? I mean, HPC and AI is the heart of new algorithms and new innovation, right? And when the pandemic started, there were no tests available, right? And I mean, today you can go buy a test, at one of the stores around the corner, right? A home test, right? So, that is really where I think these changes happen, right? And memory and storage, it's incredible to see what technology leaders are doing, right, to advance memory and storage capability. I believe that storage is the unsung hero of HPC and innovations in this area, right? These keep the HPC systems humming and make it possible, right, to leverage all the data. I'll give you an example, right? The transfer and movement capabilities, that we're seeing in advances like Samsung's DDR5, DRAM memory portfolio. First 512 gigabyte DDR5 module, right? They deliver over 2x the performance of DDR4, right? But the key part is you couldn't do that. You had to go and break up the problem into multiple things. You lose precision. But with the advancements that we're seeing in like DDR5 and what you have done, right? Now you can do that in in one node, right? You can have better precision. Anytime you break up data and do it on multiple nodes, you're going to lose precision, right? And so you build better products that way, right? And I think this innovation, right, will fuel the most demanding data intensive workloads in supercomputing, right? From the edge to the cloud. And I'm super excited, right, to be partnering with Samsung, right, to support this in our next generation Xeon processor, Sapphire Rapids. The HPC industry is waiting for that product, and super excited with Sapphire Rapids and Samsung's DDR5.
Great. We're excited too about the partnership. So I guess building on that and maybe drilling down a little bit more on Intel now. So tell me a little bit more about how Intel specifically is responding to this rapid evolution of HPC.
No, absolutely, right. And Intel, we're investing in all the right technology, right? We have recently, invested in a $20 billion investment for fabs in Arizona and New Mexico. Greatly support our customers in the future. Our mission is to continue using Moore's law, right, to further enhance the performance of every product we bring to the market, right? Uh, we have acceleration in every Xeon processor. It's a great example, right? Which is from your laptop to your data center, right? We have a DL boost technology. So when you go buy a laptop today, it's ready, right? It has all the same high performance computing and AI features on your laptop to your data center, right? We have an integrated GPU technology, which we call XC on a client laptop. And our exascale system is going to have Ponte Vecchio, right? So we're investing in technologies so that this evolution of HPC, we have it well covered. We also have very innovative technologies like speed select technology. A lot of times when somebody's running a data center, you really want to have some applications using 8 cores and some using 24 cores and some using 32 cores, right? So we have the speed select technology, which gives you a deterministic cluster. So you basically get a 3-in-1 processor. Okay, so it really helps also get best performance per watt. You don't lose, don't waste your power. And most importantly, our ecosystem partners, right? We are very close with the ecosystem partners, working very closely with them to make sure they're supporting our technology and product plans, and we can support their technology and product plans, right? And that's where I think, our close partnerships with leading players like Samsung, right? We can move faster, test earlier, push boundaries together, and another example, right? I mean, our partnership, with Samsung to deliver DDR5, right, with Sapphire Rapids, it's a perfect example. Super excited about it, especially for my business. Okay, thank you.
All right, awesome. One of the things you touched on briefly, you mentioned exascale. So this is kind of one of my favorite buzzwords that you're hearing about more and more nowadays. And this is really a massive undertaking to say the least. So from your perspective, Nash, like what are the technical challenges that designers are facing in terms of next gen exascale compute systems?
Yeah, absolutely, right. I think exascale, if I look at it, right, we are setting an example of a big exascale system, right? But it creates smaller exa class of systems, right? Which allow you to do better science, at the smallest level to the largest level, right? The big challenges of an exascale system, right, are really that of power efficiency, performance, and how do you system administrate such a big complex system, right? This is again like seen in data management, right, where you connect massive data sets with massive compute, and you got to do it without creating bottlenecks. It's a major architectural problem to solve this in a cost-effective way and be able to scale to an exascale class system. Scaling also ties into reliability and resilience, right? That are also critical when it comes to exascale, right? When you have thousands and thousands of nodes, you want to make sure they're all collectively working, right, to go and solve a solution. So for some of these reasons, HPC systems are designed to cost effectively mitigate this effect, right? As you scale up the component quantity of an exascale system, this becomes a critical aspect of the design so that the entire exascale system can be harnessed to take on and solve a single problem without crashing, right? So the reliability and resilience is very, very important. And then to get to an exascale class of system, right, you need to have, like I mentioned, right, open standards based heterogeneous compute environment. These exa class of systems, is all heterogeneous computing, just not a CPU. And that's why we're driving this open standards, software-based approach in the industry. And that is really going to help, right? And, you're going to hear more about our, one API at our Intel On event later this year, right? Our CEO, Pat Gelsinger, is going to be talking about this. So I'm hoping you'll be there, Jim, to see a lot more about what we're doing in exascale. And, it's going to be exciting.
I'll be there. You can count on it. So I think now let's talk a little bit about memory's role, if you don't mind. So selfishly turning to the kind of the memory ecosystem now. What advances in the memory space from your perspective do you see that will help address the evolution of HPC and the supercomputer?
Simple short statement. I've been talking a lot, right? I mean, memory bandwidth, memory is so important to the system, right? I think DDR5 memory bandwidth and efficiency scaling are key to HPC in attaining the best bytes per flop per watt.
Perfect and succinct. So speaking of that efficiency that you mentioned, so energy efficiency is obviously a concern for HPC. So what do you see is being done on the hardware side to help kind of try to improve some of this energy efficiency?
Yeah, so, more and more, power is an important aspect, right? When you go and deploy in a system. So people are worried about, hey, you know what, when I buy a system, how much power I'm going to, what's my power cost over 4 years, right? Let's say it's approximately 4 years to run the system. And, we do a lot of things to, to make the energy efficiency better. Like I explained, the speed select technology, right? That was one way. But DDR5, right, is an important aspect of it, right? DDR5 increases the channel efficiency as rates increase to provide scalable increases of bandwidth over time, right? And it starts with our Sapphire Rapids and your technology, right? And we are also supporting Gen 5, right, in Sapphire Rapids, which boosts the capability and provides robust storage and fabric bandwidths, right, at a balanced compute to memory to IO ratios. This is important for compute efficiency as well as energy efficiency, right?
Great. So let's turn take a quick turn now to talk about some applications and how they're going to benefit from the evolution of HPC, and thinking of like some new HPC projects. So is there a new HPC project that you are working on that you find to be particularly interesting at this point?
Yeah, I don't want to get in trouble with my customers, right? But I have several projects, right? Which I think it's all the way, across the world. From China to to Australia to India. If you come across all the way, I have several interesting projects working on. But some of the things that is really standing out, right, for me is the exascale system at Argonne National Labs, which is called Aurora, with the Department of Energy. I think that is going to be, that's one of the most exciting, projects, for a long, long time, right? And bringing it closer to home, I think, we just, I think won some of your EDA cluster, a HPC cluster here down the street here in Austin with a next generation Xeon CPU. And we're excited, to see how the system will enhance our collaboration opportunities between Intel and Samsung. So we're extremely, excited to work with you on the EDA side also.
We're excited as well. So speaking about that project, how is that project leveraging some of the recent technology breakthroughs?
Yeah, so let me talk a little bit about the the exascale project, right? So it's a massive and complex undertaking, the DOE exascale project. It's HPC with data analytics and AI built into the platform, right? It's intended, right, to be the world's center for advancing science and engineering research, but focus on three major vectors, right? Simulation, data, and learning. Simulation allows researchers to create like virtual representation of complex, physical systems. And they're too small or large or costly or dangerous to study in a lab, right? The use of advanced data science techniques and tools, that allows you to gain insight into massive data sets. They're they're produced by experimental simulation or observational methods, right? And the last one is learning, which is a form of artificial intelligence. Everybody will call it different terms, right? And I look at machine learning. I look at AI as two aspects, right? One is machine learning, which is the usual math that we learned quite a bit when we were in college and high school, right? Random forest, curve fitting, those types of stuff. And then the deep learning part of AI, right? Which is, trying to mimic your brain. So if you look at it, all these put together, right, is really what is driving these exascale systems, right? And I'm really excited about all the advances that is going to come out in these three areas once we have this exascale system up and running. And as a lot of people are wanting, I think you're going to see the U.S. Leap forward, right, with all our exascale systems that are coming in the next few years.
Yeah, good to see. I'd like to kind of shift gears a little bit now, if you don't mind, and talk about kind of some collaboration. And obviously, Intel, Samsung have been working and collaborating together for many, many years. It's been great to work with Intel on the evolution of the HPC and to see what is possible with supercomputing. So, from your perspective, Nash, why do you think it makes sense for Intel to be collaborating and working so closely with Samsung?
I'll repeat what I said, right? I mean, HPC requires bleeding edge technologies, right, to support the required workloads, right? Samsung has got a broad set of products and portfolio, right, which are holistic. And these products, right, along with your memory technology leadership and scale, are extremely critical in HPC, right? I can't think of having a HPC system, right, without Samsung being considered as part of the solution.
Great. And then, so another way to think about it is, how do you think the partnership between Intel and Samsung will help us get to these new exascale and HPC and AI goals that we've been talking about?
Absolutely. I think, I feel that a partnership like delivers significant value to this industry, right? As recently, our companies did a collaboration with a client and mobile business. And, as we continue to build this partnership, Intel and Samsung are recognized leaders, right, in this semiconductor industry. And our customers expect more from us, right? Our combined technology, leadership, and resources complement each other, right? So when you put them together, HPC users can do tremendous things. Like I said, right, when you think of a HPC system, Samsung is, always in play to be part of the system.
So Nash, this has been a great chat. And so now, as we start to wrap things up here, we think I'd like to have you come up with one word that we can use to illustrate the collaboration between Samsung and Intel. So what are your thoughts there?
Ooh, that's tough, and maybe I'd have picked something from my language, but Samsung and Intel, I think we have a unique but valuable relationship, right? We are customers, suppliers, and competition. To that end, it's great how our two companies share the same vision of making things possible, right? To enrich the lives of people on this planet. Thinking of it, maybe I'll have to go with breakthrough, right? I think Samsung and Intel are two leaders coming together to lead the way in memory innovation, performance, and efficiency. I think with this collaboration, we can break through and partner together to help meet our customer needs. Breakthrough.
All right, breakthrough. I love it. I think that's a great word to encapsulate the partnership and really the spirit of what our two companies are championing. So again, Nash, I just want to say thank you for taking the time to chat with us around all things HPC and supercomputing, and the incredible Intel and Samsung collaboration opportunities that we're really just starting to work on together. And we're really excited and honored to be on this journey with you. So with that, just thanks again, and looking forward to meeting you in person here real soon.
Thank you, Jim, and looking forward to meeting you too.